All right, welcome back. I hope you all had a great lunch. So next speaker with me on the stage is Pierre, and he will talk about the security of the backbone of the internet and malware on core routers. Please give a warm round of applause.
Thank you. So, as said, I will talk about software vulnerabilities in core routers. First, who am I? So, I'm not a security researcher. I'm a network engineer, where I focused mostly on IP/MPLS core network security. I was at network operations for a long time, for my whole career, basically. And on a side note, I'm a member of a specific community of 120 experts at Orange, where I can dedicate 10% of my time to side projects. And this research is the result of, say, 10% of my time. And I'm also a ham radio operator, a scuba diver, and my own personal ISP. So first, a bit of context. What is a backbone? So the backbone is a core network of service provider or an internet service provider. It can be used to transport internet traffic for residential and enterprise. It can be also used for enterprise VPN, think big corporations that have hundreds of sites across the country, but also mobile data and voice will be also transported on the same network. So as you can imagine, it's a very critical piece of infrastructure. When we are talking about routers, what are core routers? So you can imagine that they are quite different from your home router. This picture is a bit of an old piece of kit, but the form factor is quite the same today. We can have ports from 100, 400, now 800 gigs per port, around 20 to 24 ports per line card. So here you can see we have 20 line cards per router. And 20 line cards per router, you can imagine that's a lot of bandwidth. So it's a target of choice because it's sitting at the heart of the network of the ISP. So for that presentation, I will talk first about some past attacks and research, interesting research I would like to share with you. We'll see then how the evolutions in software router architecture made possible some new vulnerabilities, and we'll conclude on that. So the first attack I'd like to talk to you about is not on routers, but rather on switches of the public telephone network in Greece in 2004, 2005. So a Plex rootkit was deployed on said switches to reuse the functionalities of lawful interception. And those features of duplicating the the telephone traffic enabled attackers to receive a copy of all the phone calls on prepaid mobile calls. The rootkit was discovered because an upgrade, software update of the rootkit caused operational issue to Vodafone, and they investigated with Ericsson, sorry. And during the investigation, the switches were rebooted, and so all evidence was lost. So we know that it existed. We don't know who was behind. We don't know exactly why. But this was an interesting piece of malware, like more than 20 years ago. The second case is well known in the industry, Stuxnet. So Olympic Games campaign. What I'd like you to remember about that campaign is that even if your infrastructure is air-gapped and there is no network link between the critical infrastructure and other side of the internet of other networks, if you are a valuable enough target, you will be breached. It's not an when, not a if, but a when. Continuing on the state attacks, the state room collection program. So those were very interesting piece of malwares developed by the NSA to target specifically Cisco firewalls, Juniper firewalls, and Juniper routers. And to my knowledge, this is the first evidence we have of router malware that existed and were deployed in the wild. Those malwares were highly custom and uses multiple zero-day for initial infection and persistence. Another malware, also probably of state origin, that was not a router malware, that was standard computer malware. Red October But it was interesting in that if your computer was infected by Red October, it would scan your network, your LAN network of your company, for example, and it would try to find Cisco routers. And if it found Cisco routers, it contained about 600 SNMP communities, and it would try to extract the configuration and then upload it to the attackers. Affected customers were, for example, government entities, diplomatic targets, and Orange customers were included in the net of the attackers. Continuing on these attacks, we have true supply chain attacks. So we talked about software chain attacks in the past, software supply chain attacks. This is hardware supply chain attacks, where we can see NSA employees here opening Cisco packages and with the classical Cisco console cable, they were implanting a software implant on the routers and then repackaging and shipping them to customers. So you would get a new brand new piece of kit from Cisco, but the malware was already implemented on the hardware. The other picture here, where we can see a mod chip. So this was based on a research published by F-Secure called the Fake Cisco. So the mod chip was not to allow spying on users. It was to bypass software checks, software signature checks, to allow for the genuine Cisco IOS to run on counterfeit hardware. But if that mod chip was enabling software checks to be bypassed, what also was enabled by this mod chip, we don't know, but that's worrying. Another very interesting attack was the takedown of Viasat network the day Russia invaded Ukraine. So initial access was through VPN concentrators, and then they took over the provisioning networks, the management networks of the remote modems, and then they deployed a wiper that was targeting the MIPS architecture the routers were using, so that all the OS of those modems were wiped. This is quite interesting because it shows the kind of damage you can do to a country or to a continent if your admin network is breached and the provisioning system compromised. Just a few years after, Gmagic. Gmagic is a piece of software that was called like that by the folks at Lumen on the Black Lotus Research Lab. Gmagic gets especially GNOS routers, Juniper router that run GNOS. Very interesting piece of software that uses eBPF to listen for magic packets without opening any socket. So it is very stealthy. It uses like port knocking, if you want, so you would not have any open socket. And when knocked by the attacker, it will spawn a reverse shell to the attacker-controlled system. And also, an interesting piece of information was that the processes were hidden on the system in plain sight, like kernel thread or legitimate process names. We don't know much about the targets, where it was found. We just know that, okay, this is real. We were having small modems, for example, with Viasat, and now we are talking about core routers now. Salt Typhoon, I guess most of you are aware of that group of attackers. So a Chinese IP that target telco infrastructure. Usually they went in through various vulnerabilities, well-known vulnerabilities like Cisco Web Interface insecurities, Smart Install, but it was almost never 0 days. And then they would create new user accounts, they would use GRE tunnels to connect back to their infrastructure, and they would inject routing, they would inject prefixes, subnets into the routing tables to be able to null root 6 log or to hijack the authentication servers. Very interesting in terms of techniques, not much in terms of malware. But this showed the state of the actors that are targeting telco networks. And last but not least, we have the Red Penguin malware incident. So this one was revealed by Juniper. like Gmagic, we do not know much about the targeted customers. We just know that they found several strains of malware that were, some were highly custom, some others were based on tiny shell that was adapted to run on FreeBSD. Processes were also hidden on the system, like legitimate process names, so that a network engineer who would find such process name would not panic and not raise any suspicions. It used crypto for command and control. That was quite interesting. And one remaining question was that how was veryexec bypassed? So I will talk about veryexec in a few. In terms of research, there have been several over the last 20 years or so. One very prolific researcher was Felix Lindner at Funnelit. He published a number of talks about the security, or rather the insecurity of Cisco IOS. But his research was very low level. He was a security researcher, which I'm not. So he was able to reverse engineer the Cisco IOS, which is a simple, well, no, a single binary, and he would be able to find protocol passing bugs. He would be able to enable remote debugging with GDB and to do some exploit detection. In the same years, we had also Sebastian Muniz, who found also similar things on Cisco IOS. It was still very low level. He used Dynamips, for example, to emulate a Cisco router. Yeah, very hard research on the topic, way out of my league, for example. The fine folks at ERNW did an amazing research on Cisco ACI. So Cisco ACI is quite far from Cisco IOS, if you know Cisco IOS. We are entering the data center world with new kind of switches and a lot of Linux utilities that are now on the switches and on the controlling software. So their paper was presented at Black Hat in 2019. And so we found new vulnerabilities, new kind of vulnerabilities that we haven't seen before on network equipment. And that's what I call cloud-based networking certification. Also, if you care about backbone security, it's not about the OS, but more about the protocol. Eno published at Black Hat Europe 20 years ago MPLS and VPLS security. So if you care about network security, this is an interesting read. Now with some other researcher, someone called Heim Darkness published 2 local privilege escalation for Juniper GNOS. So those were published like 5 years ago. The first one was using ETH trust root. So ETH trust root is an open source component that is used by Juniper on their system. The binary was set to the root, and it uses two things. The first one was that var TMPs were writable, and the log file was created with predictable name. And combining those 2 features, he was able to overwrite cron tab, and cron tab would be executed as root and so on, launch the payload. And the other vulnerability he found was on Mosquito. So Mosquito is a well-known MQTT broker that is used also on Juniper GNOS. Mosquito also runs SUD root. And if you are using Mosquito-C, the file passed as arguments will be displayed on stdout. So arbitrary file read vulnerability. Another researcher, kind of the same type of vulnerability, Xylitol. So he found security feature bypass. So I just talked a few seconds ago about veryexec. So veryexec, verified exec, is NetBSD technology that was ported to FreeBSD by Juniper that allow Juniper to restrict the execution of non-signed binaries. So if your binary is not in the digitally signed manifest, you won't be able to execute your binary. And Xylitol was able to find a bypass. Okay, so he would be using Juniper in a VM. So he patched the BIOS and so on. So that allowed him to do some bypass more easily than on a router, but he was able to bypass it nevertheless. And one comment that he made on the topic of GNOS security was that he was surprised that an OS that used on many high-value routers and switches would have such easy-to-find bugs, and the lack of mitigation made the situation even worse. So remember that. But this guy was still reverser. He was still a security researcher, and he still had to reverse assembly code to pseudo C to get his vulnerability, to find his vulnerabilities. So, as I said, we've seen that both attackers and researchers shifted from embedded low-level malware on telco equipments, dedicated telco equipments, to open source vulnerabilities on IP router OSs that are based on open source components. The skills needed to perform impacting attacks decrease. Before with Felix and Sebastian, those guys were legitimate security researcher. Now, if you find an open source vulnerability that is not yet patched, you can attack a router with it. And that's where the containerization of telco equipment attracts also more attackers. And the last thing is, we used to be quite invisible to the eyes of the attacker. The infrastructure was not a target of choice for the last 20, 30, 40 years. But we've seen that with Chinese IPT, for example, so Typhoon, that it is not the case anymore. So what evolution in terms of router architecture made all this possible? So Juniper does not exist anymore as a company. It's now called HP, but it's still GNOS. So this is the architecture of the legacy GNOS. So we have here on the top, this is the OS that is running on the routing engine. So the routing engine is the CPU, is the computing process of the router. And on the bottom, we have the line cards. So the line cards, they are the interfaces, the ports towards the core or the customers. So GNOS is based on FreeBSD, somewhat custom with a limited code base because the FreeBSD is a bit trimmed down. We have security features, some of them, like secure boot and very exec, as we saw. But also we have some security features. We do not have much hardening, but I'm getting ahead. This is how very exec manifests itself. So I have here an arbitrary file on my router. You can see that I'm connected as root on the FreeBSD shell of the router. And if I want to execute my binary, I won't be able to. And this is a very noisy process that will put IOCs, or at least indicator of tentative of compromise, in the log. OK, this is great, but the system is not particularly hardened. So here we have two different routers. And what I'm doing here, this is the GNOS equivalent of a PS. So I'm listening all the processes on the router. I'm counting them. And we have like a lot of processes. And almost all of those processes are running with root privileges. The only processes that are not running as root are the ones that are handling my TTY, my CLI session. So yeah, this is not something that we should be very happy about. The network attack surface is particularly broad also. We have a lot of, so show system connection is just a net stat under the hood. And we can see that we have a lot of processes that are listening on the interface on the router. This is somewhat interface dependent, so if you have more interfaces, you can have more listening socket, but most of the processes are listening on any interface because the interface can go up and down. So to be easier on the software development, the processes are listening on any interface. So we can see on two routers here that we have between 60 and 80 processes that are currently listening on the network. If you want to go further than that, in terms of malware or operations, both, we can have access to the FreeBSD shell. So the FreeBSD shell, you can have SH or CSH shell scripting, possibly persistent, depending on where you put your script. You can have cron access also. You have TCP dump. So you are not able to dump the actual traffic that is flowing through the router, but you are able to dump the management traffic, the control plane traffic, so all the BGP updates, the routing protocol updates, you are able to dump it. And if you know your way into a router, you can also trick the router to capture some of the user plane traffic, but this is not something that is easily doable. So that means that you have to strictly restrict shell access to ultimately trusted employees. If you have some employees that have access to the router and you do not trust them like they would be root, you do not want them on the router shell. And once you are on the FreeBSD shell of the router, one thing that I'm particularly pissed about is that there is no more TACACS encoding. So TACACS is a AAA protocol that is well used on router equipment. And once you are on the FreeBSD shell, there is no more accounting. So the operations, the SOC, cannot see what you are doing. And this was changed only very recently with Juno OS 23.4. And you have to add a specific configuration. If you are handling Juniper routers, please do that, to enable shell commands to be logged as accounting. Okay, so now in terms of evolution, Juno OS is now a VM inside a KVM hypervisor since Juno OS 16.1. Juniper justification is to provide increased control plane scalability and performance. So security is not a goal, so that's good. This is what it looks like. So compared to the other schematic we had before, where we had the FreeBSD Juno OS that was running on bare hardware. So here we have a first routing engine, so that's a card on the router. We have a second routing engine, that's also a card, and we can have a number of line cards. Each card has CPU, memory, storage, and we have a Linux host for the case of the two routing engines, and we have a Linux that is running on bare metal on the line cards. And the Juno OS is now here on a VM onto those routers. So what it means is that the code base increased several-fold. The attack surface goes with it. If we have more line of code with this, that means we have more vulnerability to fix. But how often do we want to upgrade our core routers? Upgrading a core routers is something that takes hours. So to upgrade with customer impact. So to upgrade a whole network of an ISP, it can take up to 1 year, 2 years in some times. So we can't upgrade routers like every 3 weeks like we would do with other equipments. And what's interesting with that new technology is that veryexec is gone, or at least veryexec is still present, but only in the Juno OS VM. So if you are on the router hypervisor, so here node, it's the hypervisor. We see that it's a Linux, not FreeBSD, and we can execute any binary we want. So we had security features, and because the architecture changed, those features are gone. So in terms of new vulnerabilities, Juniper said that only Juno OS VMs are supported, and we cannot run third-party VMs or those routing engines. So this looks like a challenge. Well, not a really interesting one, because it's just doable. If you are root on the router, you can just spin a rogue VM by launching QEMU. You can also use libvirt if you want, but QEMU works. And a very scary thing about that is that it allows an attacker that runs a VM on the router to have access to the out-of-band ports on the router. And when he has access to the management ports, he has access to the management network, because the ACLs, the firewalling, is done on the Juno OS VM. The host is not supposed to have access to the management network, but once you have your own VM, you can do whatever you want. The VM, once on the router, it's not that visible. There is an additional QEMU process, sure, okay. It's only visible from the Linux host, so no amount of SNMP polling or CLI from the Juno OS side will be able to see it. And even if you are on the node on the router and you do virch list, if you have launched the VM just with QEMU, you wouldn't be able to see it. But okay, QEMU still requires root access. So what does it require to get root access if you're not root already? So we've seen that we have multiple VMs. The line cards are also Linux-based server. How difficult would it be to gain root access? Turns out, not much. This is an extract of a script a shell script that is run on router startup and at specific intervals. And if you can remember one of the previous vulnerabilities that was found by IAM Darkness, so VAR-TMP is worldwide table. And what are they doing? They are using files within VAR-TMP, and they are executing those files from VAR-TMP as root. So that's a local privilege escalation. That was reported to Juniper a bit more than a year ago, in March of 2025. That was acknowledged and published as CV, not published, assigned as CV 2025-30661 in May, and published during the security bulletin of July 2025, with a score of 8.5 on the CVSS 4.0. But Juniper doesn't have any bounty money, so that's too bad for me, I guess. But wait, there is more. So remember, this is the architecture we have been dealing with now. So the management port, as I said, once you are root on a VM, once you are root here and you spin a VM, this is a Linux bridge. So your VM will be having a tap port in the bridge and have access to the management port and the management network. And so this is another vulnerability that I found just by accident. So there are two ways of connecting to a line card when you are on the JunoS CLI. One way is through the internal serial ports, or the other way is through the Ethernet switch, where you have IP connectivity from the main routing engine to the line cards. And what happened is that Juniper just forgot to ask for a password. And they gave you root access to the line cards, even if you are just a plain user on the JunoS CLI. Wow, okay. So you are root here on the FPC1. FPC, it's the name of the line card. But what can you do with root access here on a line card? Well, a lot of things. Because Juniper is using RSH and rlogin internally in the router. How does RSH security works? Do any of you are old enough to remember? Rlogin and RSH works by comparing the source port. If the source port is equals to 1024 or less, that means that you are root on the local system. So you can gain root privileges on the remote system. That's why you are able to go from the line card to the JunoS as root, so using the Ethernet switch and the IP network. Yes, they are still using RSH in 2026. This is bad. And from there, when you are root on the JunoS, you can use the built-in SSH keys to go from the JunoS FreeBSD shell to the Linux KVM host, and there you are also root, and you can spin your own QEMU, ROG VM, and so on, like I said before. This was reported the same day to Juniper in March of 2025. A CV ID was assigned in May also, and this was published only in April of 2026. 13 months for Juniper to publish a fix. And they did not even publish a workaround, even though I provided one. So that's something I'm quite pissed about. What I'd like you to remember here is to never treat router CLI as secure, even though it looks like a walled garden. It looks not as open as a shell CLI. It is. So only consider trusted employees, trusted members of your organization to have access to the CLI. All right, so Juniper has its fair bit of vulnerabilities. Is it any better with Cisco? So I'm talking about Cisco IOS XR. So IOS XR is a carrier-grade OS of Cisco. It's used on telco routers from small 1 or 2 rack to rack-size behemoths, like you can see behind the mesh, the noodle, whatever thing. And so, like JunoS, there was a legacy architecture that was using QNX real-time operating system, and QNX was also running on the line card. That was called XR Legacy. And since iOS XR 6, they went all in with the virtualization. So we now have Linux hypervisor that is running on the hardware. And we have a first VM for the iOS XR. We have a sysadmin VM that is used to launch the other VM. And this is the same on every line card, with containers, LXC or Dockers inside the VMs. So this is how you go from one context to another. This is something that even a network engineer that is dealing with this kind of hardware every day, this is difficult to remember. This is what it looks like, because if you are looking at a router, this is what you should be having in mind. This is not a router, this is a virtualization cluster. This is one card, this is another card. And you have a number of line cards on the router. Each line card has multiple OSs. That's a lot of places to hide code. That's a lot of places where you can lateralize from one card to another, from one context to another. On the various OSs of Cisco, there is no execution prevention. So if an attacker is able to put a malicious binary on the system, he is able to run it just fine, like there is no hardening at all. The same kind of insecure practices are used by Cisco, like sourcing from VARTMP. This is something that they do also. The only thing is, file system access is a bit more restricted on Cisco IOS XR than on Juniper, but I'm sure that there are other vulnerabilities on that side. That's just, I haven't found any yet. And Cisco was very happy to promote this with Cisco IOS XR 7. So XR 7 is a bit old now, but contrary to Juniper, that says you cannot run third-party VMs. Cisco say, okay, you can run third-party VMs, but is it a good idea? They also allow an attacker or an operator to run with line card access. So a third-party VM that is running on the router has access to the traffic, the actual router traffic. Overall, code quality seems a bit better than Juniper's, but I'm pretty sure that we can find other vulnerabilities on that side. So, what we can conclude about this? Big routers, they are not that scary inside. If you already know Unix, you should be fine as security researcher or as attacker. We had very specific, very targeted router malware for very specific architecture. We've seen that just a shell script can work just as well now. And network security, you have to remember that it goes well beyond securing the protocol. We've seen a lot of talks regarding BGP hijacks, DDoS protection, and so on. But if your router is built like with no hardening like we've seen here, it doesn't matter because an attacker will be able to gain root access on your whole network. So what I'd like you to know, to do, if you are a vendor, I don't know if there are some in the room, please apply the most hardening you can on the router. I don't want this shit to run as root privileges with SUD root and so on. I want also quicker and hitless upgrades. That's a major pain on telco equipment. That is the duration it takes between a fix when it's published and when the whole network is fixed. And don't treat shell script security as less important than C code. It is that important. If you are root with a shell script, it is the same as root with another exploit. If you are running equipment like that, please monitor your gear. Be aware of the attack surface of the software that is running under the hood. Do active polling of every layer of virtualization you have within your routers. This is not limited to the active network OS. You have to go to all the underlying OSs that I've presented to you. You have to upgrade quickly, so that I know that it's a bit difficult when upgrades are service impacting and it takes a long time, but you have to upgrade quickly. and decommission end-of-life equipment. As soon as the manufacturer is not providing any more updates, upgrades, you have to think about decommissioning those equipments. So that's my key points on that and what I would like you to remember about this. Thank you.
All right, thank you very much. Are there any questions in the room?
Thanks for this, quite inspiring talk. What do you think is what's your guess? What is the motivation of the vendors like Juniper or anyone else to be so, let's say, I would rather say careless and so sluggish with hardening or with getting your information processed so they fix their products? What's your guess on that?
Well, security doesn't sell. I mean, it's a cost. You can't sell security. The customer, they will buy anyway because they are not interested in the security features of your router. They are interested by network features of your router. So you won't be able to buy it if your BGP stack is broken, if your forwarding is poor or things like that. But if your security is poor, it doesn't matter. It's not on the RFP that you will publish to vendors. So for now, if the customers are not voting by their wallets, by choosing vendors that are more security conscious, it won't change. So for a long time, this is something that I've been talking privately with vendors. And I'm a bit fed up, to be honest. And this is why I go public with that kind of research.
Okay, so not putting words in your mouth, but you're saying it really is about that they don't want to spend money on that. It's not that someone intentionally leaves certain weirdnesses in their products, maybe for others to use these weirdnesses. Nothing like that. It's not a conspiracy thing, like I don't want to get in this rabbit hole, but I'm surprised about that ignorance.
Okay, we could. But when you think about the inequality of, I don't know how to say, but the level of vulnerabilities, as I said, I'm not a security researcher, but I was able to find glaring vulnerabilities in those routers. If they wanted to put intentionally backdoors in their equipment, I guess it would be less obvious. It would be more discreet.
Okay.
That's a guess.
Sure.
Actually, on that one, not necessarily for core routers, but for other security hardware, by professional experience, sometimes there are really dumb backdoors left behind. And trying to have that fixed through the manufacturer gets you, at least in certain no longer EU countries, a nice letter to cease and desist.
Any other questions? Well, then give another round of applause to the speaker.
Thank you.